There are a lot of different C++ libraries out there, and I'm going to make a video, this video, that kind of explains what they are and how to start creating your own. So that's pretty much it. So what is a C++ library? It's basically code that you can bring into your projects. Just think of it that way. It's just pre-built stuff. Libraries. And if you want to build your own, well, why would you do that? Basically for portability. If it's something you want to reuse or you think other people could find useful, or it could be used across a lot of different applications, it's not if it's not super specific. That's why. So I just did a Google search for C++ libraries, and we can look at some of these top ones and what they do. Poco is some kind of networking library, so it just basically helps you do server transmissions. Uh, ASIO is a similar thing. OpenCV, I don't remember. TensorFlow is all about AI learning stuff. Eigen, I'm not sure. libsoundfile, this helps you open binary sound files like waves and stuff. So a lot of these programs just interact with your operating system. They're designed to spin up certain things like your network or your something. When this libsound one just knows how to unpack files basically of certain types and help you load them to play back. So, it's all kind of generic stuff that would be used over and over across applications. All right, so let's walk through how to build one of these, because that's the main thing here to take away from this video is just how to actually do this. And let's make it really simple. So first we're going to launch Visual Studio. I'm using Visual Studio 2022. You could be using a different one if you want, that's fine. But this version is the latest as of the recording of this video. So let's go ahead and open this. And in this interface, when you open it for the first time, you should have it getting started. Well, you can create a new project, continue without code. Let's go ahead and create a new project. This is basically just going to give us a little bit of boilerplate that they add in, which is fine. We can figure it out from here. We're going to do a CMake project. A CMake project is very portable, is the great thing about it. There are a lot of frameworks you can build around and stuff like that, and that's up to you if you want to do that. But I'm just talking straight C++, and CMake basically just helps sort out your compiling commands. And you know how normally when you compile with C++, maybe you know, maybe you don't, but usually there's a long console command of all the options. CMake basically helps parse that, and it's very useful. I happen to have a lot of videos on it. MFC app is basically a Microsoft Foundation class. This is very just Microsoft specific. Now we could spin this up on our own if we wanted to. That's just a different boilerplate. So let's just do plain CMake for this. And we're going to make a somewhat of a nutrition app. We're just going to kind of track nutrition with this app or with this library. So it's just going to be kind of a thing you could bring in if you want nutritional tracking in theory. So that's the point of this. It doesn't, a lot of libraries are more specific to hardware coding things, but there's also ones for just supporting other stuff. So you'll find a lot of libraries made for the sciences in general. What do we call this? Nutrition app? Almost went with nut app. That actually has a interesting ring to it. Nutrition app. Just gonna call it plain old nutrition. And I googled it, so I know I spelled it right. Okay. So your interface should look the same if you're choosing the same options. Otherwise, sort out as required. I'm gonna go with place the solution and project in the same directory. That's just the way it structures CMake. We could always change that later. Just a few add subdirectory things in a project top level. So we'll go to the Solution Explorer. When you get this page, yours might look different. You can sort out some of your stuff by going to Window and showing windows and stuff like that. but you should have a solution explorer somewhere. And to start, we're going to change this to all files. So let's just make sure we have that set. We're going to click up here, this little button, switch between solution and available views. And there is a folder view and a CMake targets view. So CMake targets view specifically shows what CMake is pointing to. So it's a bit of a different setup, but it allows you to build stuff individually in hierarchies. So that's kind of cool. And if we go to it, we see we got nutritional app there. All right. Well, let's go back to the file structure though. So we'll click it again, folder view. All right. So it gives us basically a CMake, some presets. Don't worry about those. Nutrition.h and .cpp. If we look at these, we'll see that it is a main. This is not a library. So let's change it to a library. Well, first of all, we don't have a main if we're a library because we're basically just chunks of code that can be added in. So let's have an eat function, and let's take in a struct called nutritional values, and we'll fill this out as we go and probably move it to another file, but we want things like a float value called calories. So let's say that we just, as the main take in for this library, we're going to eat nutritional values or food, whatever you want to call it. We're calling it nutritional values. We're going to take this as a const reference, and we'll just call it value. So what does it do with it? So this is where our library would begin its process of doing something. We can sort that out a little later. For now, let's go ahead and go to the header, get rid of this IO stream. Actually, we can just get rid of this entire thing for the most part, but we do want to forward declare our functions and stuff. So that way, whoever uses this app knows how to fill out nutritional values, for example. We can get rid of this namespace standard too, but yeah, let's go ahead and do that. So I'm just going to move this into its own file and just put it in here. And so you do have to decide what happens here. We probably want some kind of set to create of all the things we've eaten and add them all together or something like that, or maybe have days or a reset button. I like the idea of having just kind of a total list of everything and a reset button. I think that works to start. So let's do that. So let's make another struct just called nutritional totals. And this is going to hold a vector of nutritional values. So that way we're going to save everything into this so that we can calculate it on the fly or parse it. But that'll be for a later date. Don't necessarily need to save this data unless you're planning on accessing it and playing around with it more later. But that's up to you. It's going to cause some copying, but it's not a big deal here. Most likely copying, depends on how you're doing it. So maybe, yeah, that's all we'll do. So we'll just add to that. Now, this thing doesn't know what a vector is because it's part of a template library. It is basically a dynamic array. So just think of it as that. There's more to it, obviously, but that's how we're going to use it for now. Because, well, the thing is, we want it to be dynamic, so we don't know how many things you're going to pass in necessarily. It's not a specific number. And now what we could do is we could just instantiate something here. Like, well, we don't have any classes or anything. We haven't really gotten to that. So let's not worry about it. This is a library. It's got its own space when you run. So what if we just declare like current run values, which is just these nutritionals total current run values. And let's have like a helper function that just resets it, or we could say like new day. Let's just do new day, and all that it's going to do is just reset this. So how do we reset it? Well, currently it's just going to be, well, a list of values, so we would just get rid of them all. We could do that by calling the values.clear. Now why does that work? Because, well, this is just a vector of nutritional values, and when you clear it, you remove everything from the list. Now, this is kind of packed into another struct, which might seem a little bit weird, but the thing is we're going to have things alongside this at some point, and things that support it. This might make more sense as a class later, but for now, everything being public is fine because we are in the very structural development. No need to overcomplicate anything just yet, in theory. Okay, so what do you do when you eat? We got to fill this out, and I think we are probably where we want to be. Well, whatever value comes in, we can just push it back to this. Now it's going to do a pushback. Now this is a const reference. So what should happen here is it should force it to copy, basically. So it's going to copy this value in. And that is probably what we want in our case. It sounds slow, but the thing is we're kind of hard saving everything dynamically. So we kind of want our own copy of it. But that means the client could then toss their data if they wanted after they passed it in, because we have a copy of it. Hopefully that makes sense, but that's kind of important to think about when you're designing things. Okay, so I think we're actually good here. Let's just make one more function though. Nutritional totals. We want to let's just get total calories or something. Just some helper functions. And all this is going to do is return basically all the values. All their calorie totals. So we got to go through each of these and just add up a total. So I guess, I don't know, we'll do that however we feel like it. We could just type it in here, or we could put it in a lambda. Another way we could do this is with the accumulate from numeric. We basically can use this function and give it iterators and give it an init value, but this isn't quite right yet. We also need to do another thing. We need to overload the plus operator because this is attempting to use the plus operator by default, and that doesn't exactly work unless we set it up for this because it doesn't know how to plus to nutritional values, but we can tell it. Basically, we want to just do the calories of each. And sure, we could do this all manually in our own for loop, and maybe that's more simple. But the thing is, maybe this plus operation will come in handy later. And that way, when we need to edit code later to update this, we basically just update the operator, and all this code like over here can stay the same. So let's do that. I'm trying to think off the top of my head how to do this. Gonna give it a quick yes, and then I'm gonna Google it. I guess we want two different types of these. We want a nutritionals values one, which might belong somewhere else, like in this header alongside it. And we gotta make sure we get in these paths in left hand side and right hand side. I guess we just edit the left hand side. Yeah. I think we could actually, can we return void here? I forget. Okay, well, I'll look that up in a second. I'll actually do it now. Okay, I guess it depends how we're doing the function. If we're doing it inside a class, it's different. So if we put it into here, there we go. So then what it would do is this calories, which is the one it's operating on. And we're just adding this right hand side. So we just do a plus equals here. Make sure we're getting the calories out the right hand side. So we basically, any of these values, we just need to have them all populated. So as we add more, we will do that. We'll add one more. And the value we're going to add is salt. And we want to just make sure to add these as well. So hopefully you can see how to extrapolate here and add as many as you want. But this, we'll come back to this a lot because if we want to change or add or remove, we just do it in one spot. And all the front end stuff like this accumulate should just work. I think I got to figure out one more thing on this accumulate. I don't use it too often. It's actually kind of new. But you can do all sorts of cool tricks with it. Okay, well, on further inspection, I might be over-engineering this. So I think what I'm going to do is, sure, we'll leave this plus equals code. That might come in handy. But we're just not going to use accumulate yet because I think it's going to type and return another value. And yeah, I'd have to do it differently than I'm currently working up. So when we call this, we'll just kind of hard code it. So that should take care of it. We just want to be sure to initialize. Okay, so this is looking good. Now what we must keep in mind is that this side of things, we're actually going to make that go into the CDP. There's a reason for it later. You know, we'll actually just remove it. Sorry for the troll on that. We might actually just put it back later. So if you have in your code, you can comment it out or whatever. It's fine. But the thing is, I think if we do it out of scope of the class, then we have to take in. Let me see if I can just correct this real quick. But yeah, I'll get back to the main thing shortly. I think you just do it like that. You add it to the left-hand side. Or do we return a new one? Okay, I think this will actually work. This seems really weird though. Maybe I should just declare a new one. So these ways might all have their advantages. These different ways I'm kind of going about could all also handle memory the exact same depending on your compiler due to optimizations. So I think this is the most proper way to do it though. And we can take this one in its const as well. A little bit of a heavier version, but it's safer, I think. Okay, so yeah. Point I wanted to get to very quickly here was how to actually expose stuff properly. Okay, so from the end user, the person who wants to run this and do the new day eat thing, those need to be public. Those functions need to be accessible to the user. So we just need to forward declare them. Don't need to define them yet. We just need to say, hey, these are callable. But the code of what they actually do is going to be hidden. Kind of an important distinction that we might get into a little more. So this header is kind of working like a public header, and this is kind of working like a private file because it's going to be hidden behind a library. When a library is built, it is just binary code, and you don't need this CPP anymore. You have the binary code already ready, and you just link it to the rest of your code. So this is not going to just run on its own. It doesn't have a main. Let's go to the CMake where it says add executable. Let's change this to add library. We can leave it all default. It's going to build a static library by default. And that's all it takes. Now there's nothing to run here, but we can go to build and build all. And we can still build the library, but to run it, we need a sub project. So let's make a folder. We'll call it tests. And we're just going to add another CMake file in here. And in this CMake, well, let's, enable testing here on the top level one. And then add subdirectory of the test folder. And now we can fill out this test one. So that's all you need to do on the top level. This one, we essentially want to do the same thing. Let's go like so, and we're just going to add some executables. Executables are like little clients. We'll just call it tester to start, and we're going to feed it in a main.cpp. We got to make a main.cpp, just standard C++ stuff that you learn right off. Make an int main, return 0. Now let's go ahead and link this to our library. Our library is built earlier in the project, so this node knows about it. We can just go target link libraries. Target is our tester, and the library we want to link is exactly how it is spelled here, nutrition. And then we want to add a test. We give this test a name. We'll just call it demo, and we can give it a command. So the command here is just going to be tester. It's basically got to be an executable, and then you can follow it with any arguments if you want. We're not going to follow it with any arguments. Maybe we'll call this, oh yeah, we also want to namespace these a little bit. So let's just call this we'll put it in the namespace nutrition commands eat. So we're going to, in theory, test the eat command here. So we could pass it something, but I don't know. That's fine enough. But basically you want those dots there because the Test Explorer in Visual Studio picks them up that way. Let's have a look here. So bring up your Test Explorer. You might need to go to like Window or Test Explorer. But we just get everything to build, and it should show up in your available tests. If it does not, check your output and error list. We have some CMake errors. Basically, this library needs to be private or public. Let's make it private. And let's see if we can get it. Okay, one way you can be sure to check all your builds is just change this view to CMake targets view and see if you see everything under your project. We have the static library it shows here, and we have the tester it shows here. And this should work, but we seem to be having a few issues here. You know, the way CMake kind of wants to be designed is the project is top level, and then everything underneath is like your app, right? Like there could be a whole conglomerate of different libraries and executables under a CMake project. So keep that in mind. That is something not everyone realizes, but that's not how we have it currently designed. Because we put the main static library in the top level, which, you know, if that's how you're gonna stick with it, that's fine. But just be aware of stuff like that. I think we're all good here though, because we can build this one. Nothing to do. We can build this one. Nothing to do. Okay, so this test should work then. We should be able to see it in our Test Explorer, and there it is. Test Explorer finally shows it, and these drop downs are a little weird. Okay, I guess this top level one was the project, and then I named this namespace the same thing, and then the class commands, and then E. Yeah, that's just kind of, otherwise it'll just say undefined in these if you don't do this. So we can just run this one. And no matter what, this returns 0. We already know because that's what it does on our main. So the next step would just be to get these to work and, well, you know, make sure we're testing along with our things. The only thing we really have is eat and a new day. So, yeah, that's really all we have access to is we can make our own values. We can do eat. We can do new day. We don't have any ways to get anything here. I was kind of designing a get total calories. But this kind of needs to be outside. So what we can do is just go, you know, we've got this nutritionals total that we're kind of working with privately. So we can just return it. We can just go get, trying to think how to word this. Get day's calories so far. Yeah, sure. That's a little too descriptive. Get total calories. I just don't really like having the same function named twice here in a row. It just feels a little awkward. So I guess what we do is just take this out and just make it its own function. And it's going to operate on this current run values, dot values. Got to make sure to dot values to get to this vector. Kind of just have it collapsed in there. That might be unnecessary, but nah, I think it's fine for now. It kind of depends on how we're going to move forward, whether this makes sense or not, if you know what I mean. But that's a bit of getting into theory crafting. We're just trying to keep it simple enough to get a little example here. Just add a salt in here while we're at it. Okay, and we want to be sure to expose these in the header. That's essentially what makes people outside our library able to know what they are and use them. All right, and in our main, we want to just include our project. Now there's several ways of doing this. We can just path, or we can add stuff to the CMake to tell it to check directories. But we'll probably just path here. But first, let's just see if Visual Studio will pick this up if we just try to instantiate some values here. Let's add some artsy stuff. We're gonna need it actually. And it looks like if we right click on it, it does know how to find the headers, so that's nice. I would hope so if it's in the same CMake project, but you never know. It's kind of an IDE thing. But if it doesn't, you can obviously just reference it. You go back a path and then down into the other one. And there we go. We're able to have it in our tester and we've got it linked. Now this linking is very important on your executable. It's a very important part of understanding libraries is how to link them to a main. And this is just how you just target link libraries basically. And that's basically going to give it whatever the rest of this library built into, which is all these private definitions. They won't necessarily know them, because they're not recompiling them, they're just linking them in the main. Okay, so if we return calories, it should return 0 as the default. Let's see if it does that. It does. Okay. All right, and we're just going to add a few more tests here because we gotta and fix these. I think with the eat, we'll just confirm that the number is bigger. So we need to pass in commands here. We'll pass in, so it's going to call the executable with this as the command or as the first arg. I don't know what I'm clicking. I'm clicking the JSON second arg. So if the argc is greater than 1, let's process the other one. We'll just use string to do this to keep it simplified. And it's at space 1. Let's include string. It's at space 1 because 0 is the first arg, and the first arg, of course, is, you know it, it's the program name. So the second arg is the first thing passed in, which is at space 1. But argc should be counting also starting from 0, so that should be right. And we can just do some ifs here. So we would just kind of run a test here for an eat. Probably want to do a comprehensive test. We've got some test values up here instantiated already. I guess we could use that. So we could do stuff like, well, we just want to create something like a piece of food and set it to stuff. So it is just a struct. Let's say this food has 10 calories and 2 salt. And if we eat this food, we'll call eat on food, we should have now 10 calories and 2 salt. So we should be able to assert. Well, we don't actually want to do assert in this case. We want basically a return value at the very end of if it's good or bad. So let's just declare that. Return value. So we should see a 10 and a 2, right? We should be able to do some kind of assertions here. So we'll just do those with ifs. If food dot calories is not equal to, well, we can use our library here, get total calories, because we've only eaten one piece of food. It's this one, so it should be equal to what we ate. But if it's not, let's change this return value to -1. Which will be a return false, essentially an error code. We could check that with the salt too. Sure. Could even do some, I don't know, we could get clever and be like a -=1. It starts at 0. That would take it to -1. And if it failed the salt one too, it would be -2, just a theory. And if it didn't fail either, it should still be 0. Let's do the not equals, get total salt. The same thing there. Set this return value as maybe like a kind of a bad args, -9, -99. All right, let's do that because if it doesn't process the command, it should return a certain value. All right, so we can test a basic eat. What if we want to eat multiple things? Because these are accumulators. We want to make sure it accumulates. So let's do a food 2 and just eat both of them. Go to our test, give it a run. It passes, so we are good. You can step through this if you're having weird errors. If you want, you just right click and go to debug, or, well, I guess you need a breakpoint. I didn't have a breakpoint. If you hit F11, it breaks at your main, and there we go. So you can break into these test codes as well, just like you can any code. And this is actually how you would access your library a lot of times too. If you're stressing functions that only get called from the client, you would have to kind of debug that way on your library. Okay, I think I've gone on long enough with this episode. Hope you guys have learned a thing or two about making libraries and have enjoyed following along. If you have gotten this far, I would, I'd say congratulations. First of all, you're killing it. You're learning more than most, probably. Because this stuff gets pretty complicated and you really got to get into the nitty gritty to understand it. That's just the way it goes. But, I would challenge you to add a second arg if you're feeling like it. Have this take more commands, add more tests, because I'm going to push this to GitHub and leave the link down below and all that. All right. Well, I appreciate you guys. I'll see you on the next one. Peace.